Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hey folks, welcome again to Making Data Simple. This is where we talk about data, which I believe to be the cornerstone of life at this point. Hopefully everybody agrees that's here. But we really talk about tech, business innovation, and leadership. We're going to hit a little bit of all of those today. Thank you to the best producers on the planet, by the way, Kate Main and Steve Templeton. These folks are terrific. Don't take them. They're awesome. The topic category we have today is AI and startup leadership. We've been doing a lot of startups as of late, talking to a lot of CEOs of startups, so I think it's very interesting. Hopefully it's inspiring many of you out there to start your own startup, and good luck with that. Look, the general topic, I think, is making AI practical. My guest today is Yonatan Geifman. He's the CEO and co-founder of DECI. Yonatan, if I could say so, and then I'll turn it over to him to introduce himself more properly. But Yonatan argues that for AI to be practical, we need better algorithms, and these algorithms must take into consideration ease of deployment as much as they factor in accuracy and other elements. Welcome, Yonatan. I appreciate you being here.
Thank you very much. Thank you for hosting me.
I'd like it if you would just give us a little bit on your experience and what brought you to DECI. I mean, get us up to speed.
2 years ago, I've completed my PhD in computer science at the Technion, working on deep learning technology. And when working with that technology, I saw that it's very complicated to build applications based on deep learning, mainly computer vision and NLP, because of the computational barriers and the computational complexity of that technology. And then I started to investigate how can we make this technology more accessible, more affordable, and that can easily be deployed on any hardware in any environment. And that's kind of led me to DECI, to the point where we are today. We are making AI running better in terms of accuracy, latency, by building the algorithms automatically and making them perform better and be ready for deployment in production. So DECI is a company that builds an algorithmic platform for developers to build, optimize, and deploy deep learning models on their way to production.
Very nice. In your history, like you say, you graduate, become a research intern at Google. And located in Tel Aviv?
Yeah, we're located in Tel Aviv. Most of the company employees are in Tel Aviv, coming from background as AI researchers from academia and industry, working to develop the company technology. We have some small operation of go-to-market, marketing, and salespeople located both in Tel Aviv and abroad.
Does your technology, is it distributed worldwide?
Yeah, absolutely. So most of our customers are US based. We are working with large companies, Fortune 500 companies. And so, yes, we are deployed worldwide with many types of applications and models and use cases, as the technology is the developers' tools that is very horizontal in its essence, helping data scientists and deep learning developers to build application on whatever data and use cases they are tackling today.
Very good. Venture capital, is this a new startup, or do you see the startup as startup at this point, or is it accelerated growth because you've already set the foundation?
So at the moment, we funded with 30 million from VCs like Emerge, SquarePeg, and Insight Partners from New York. We are selling and growing our sales motion at the moment, so we can call it early growth.
I do want to break down DECI in terms of what you guys do. I'll do that in just a second, but just overall, high level, what did you see in the market that didn't exist today that you said, hey, look, this is the time for a startup. I got to go solve this problem?
Basically, we look on the process of building AI application based on deep learning technology. And when we looked at the process and the time to market of this technology, or the development cycle time of this technology, and the challenges that developers are tackling throughout the development process, we saw that a major change is needed in order to make this technology more applicable for real-time applications on the edge or other use cases that can be shipped very fast or faster than today in a scalable fashion. And this was kind of the main motivation to dive into the development process. We saw that most of the time invested after collecting and cleaning the data, most of the time is invested in designing the model, trying different types of models and different type of training hyperparameters in order to get to the right point of accuracy. And after data scientists build the model, trying to deploy it and going back and forth between production or pre-production environment and the development stage in order to improve the model, both in terms of the accuracy level and the robustness, and also on the latency and performance metrics of the model. So we try to provide developers with the ability to build deep learning technology in first shot.
Is this to say that, look, we've talked about this multiple times previously on this podcast, that it's, developing a model is one thing, then keeping it in production and deploying it is quite another. Are you suggesting that your methods deployed in production with more accuracy for a longer period of time and keep it there?
Absolutely. First of all, it's the ability to get to production on the first attempt or first development to bring a new capability, a new model, a new feature to production, and then how you can maintain that based on your reproducibility and the ability to keep the model up to date. All of this components that we provide as part of the value proposition of better model design that is based on our technology.
Is this software you provide around model design, and then you complement it with services, or do you just sell software that, alone? I mean, how does it work?
So we started with kind of a mixture, but today is 100% software that developers are using together with pre-optimized models in order to build better deep learning models. We recently published some results of our models that are called DECI. DECI are a family of deep learning models that kind of break what we call efficient frontier, the optimal known to date trade-off between accuracy and latency on various devices. And we provide them with the tool to build and get the results of DECI together with the models itself, and providing them the software to build models that are running better, getting to better accuracy, etc.
So are these pre-built models that are specific use cases in specific industries?
It's for specific machine learning tasks. You can consider, for example, in the computer vision domain, image classification, object detection, semantic segmentation, and many other tasks. So for each of those tasks, we have a specific DECI that is not only optimized for the task, but also optimized to the production hardware for one of the available production hardware that you're going to use. So for example, if I want to run an object detection model on an edge device, let's say NVIDIA Jetson, or want to run another object detection model on CPU, the best way to go is to have a different model for each one of them, optimized for the specific hardware, because different hardware prefer different type of neural architectures. And by providing a model that is kind of a composition of the data that you want to train, the machine learning task, the hardware, and the performance that you're looking to get, we can give you a good starting point that will significantly reduce the trial and error iterations along the model development in order to find the right model design, model structure for your specific application, use case, and operational point.
So basically, you give, if there's, let's say there's 10 steps in this process, you get the customer through step 4 immediately or 5 immediately, and then they finish the gig.
Yes, something like that.
More or less. I know that's our level, but we're trying to keep it simple. That's what's called making data simple. So how does this process begin? Customer reaches out, say, we're looking at doing X, then you go down the process and there's some kind of workshop?
Yeah, we started by kind of engaging with design partners, understanding what are the challenges that they are facing, and pretty immediately we saw that most of the customers are challenged with taking AI to production on edge devices, specifically computer vision applications that need to run in low latency or in real-time performance and people are struggling to build those models to run on the best accuracy and the best latency for those applications. So we started interacting with more and more customers and kind of segmented the market in order to understand what are the tasks, the hardware type, and the challenges that could make DECI as an edge AI enablement platform. And this is kind of where we are placed today, where we support out of the box with most of the major edge hardware, most of the major edge machine learning applications. And we can provide by a self-serve, completely 100% software, a solution that bring developers into production in matter of days. Now we're looking for some different or additional markets and industries after our great fit in this market entry segment. Now we're now looking to NLP in the cloud and more use cases and application. But if you take me back to the early days, it was kind of working with design partners on enabling edge AI or computer vision on edge devices to run better.
So is that really your sweet spot then? The ability to run models and keep them in production on edge devices and IoT?
Yeah. That's the place where using DESI will give you the most significant boost to your development by enabling your models to be deployable on the edge devices. It's the most prominent value proposition that we see today.
Kind of alluded to this. You've got DESI that uses edge devices. That also makes sense around your any hardware claim because devices you don't know where you're going to end up there. It's a software package. Does it push to the cloud? I mean, does it sync in the cloud, or is that in the future? You mentioned the cloud.
Cloud is coming in two aspects. One of them is that the platform is kind of a hybrid on-premise and SaaS. So you get some of the components, the SDK, the development tools to build a model to run in your premise connected to your data, but you're going through some of the optimization process that is running on the cloud in a SaaS application, which also provide you with the metrics and the dashboard of the improvement that you've got from using this technology. And then you take the model out of the SaaS back to your application, to your edge deployments or customer deployments. So this is kind of the cycle. Some of the companies also deploy their model on the cloud, and by that they are not moving the model from being hosted in the SaaS application to deployed with DESI's deployment tool in their cloud. So this is kind of another aspect of using DESI in the cloud.
Do you use notebooks as part of that SDK? I mean, like Jupyter notebooks?
So our SDK is a Python package where you can use it through Jupyter Notebook. We have some of our example projects or example code in Jupyter Notebooks, but you can also use it as in IDE, in any standard IDE. It depends on your preferences. Basically, it's a Python package that can be imported and used on any Python interpreter.
Makes sense. So let me say this back to you. So SDK, notebooks, Python, in the cloud, you run on SaaS, you're able to get metrics, dashboard, and then when ready, you push them to edge devices. And your claim, I'm sure it can be substantiated, is that you're able to put it to edge devices, keep it there the first time more than not.
Yeah, exactly. This is DESI.
Yonatan, I was looking on your site, and I don't know if this is a mission statement or not. You can tell me. Let me repeat what I saw, because I was going to break this down, but I think we've hit on a lot of these topics already, which is great. We provide a proprietary optimization technology for deep learning practitioners that complements their techniques like pruning, quantization, and NAS, enabling you to accelerate deep neural network inference on any hardware while preserving accuracy. Well, first of all, the question is that more or less your mission statement? And the second part of that question is, I got to believe it was intentional, all those words. And I was going to break down those. I'm going to ask a few questions on those if you don't mind.
Yeah, sure. So go for it.
All right. So at least I got it. Oh, proprietary optimization technology. So it's proprietary. I'm not asking you to give up all your secrets here. But what is the differentiation you believe you have in optimization technology that you just can't find in the market?
Our optimization technology is based on neural architecture search technology, Our algorithm name is AutoNAC, Automatic Neural Architecture Construction, which is basically searching for optimized structure of the neural network. The structure of a neural network defines both the accuracy that it will get on the data and also the latency that it will run in production. Optimizing the structure of the neural network kind of let us find the best operational point between getting the best accuracy or getting the best latency that we want in the application. And when I'm saying searching for the structure of the neural network, we need to understand that in neural network there are millions and billions of neurons, and how to kind of compose neural architectures, how many layers, how many neurons in each layer, and how can we build those architecture is a very complex question in terms of searching for those structures. And in order to do that, we need to find a very efficient way to search among hundreds of thousands of candidates neural architectures that we can automatically generate, that we call them the neural architecture search space. And we need to search efficiently on that search space. And actually, the core technology of the company is an AI algorithm that drives that search in order to converge fast to a candidate model that is performing very well in terms of accuracy and latency. So it could be preserving the accuracy for some latency level or getting some latency level with the highest accuracy available. This is kind of the constraint optimization that we can drive the algorithm to converge to find neural architectures that satisfy the performance or the characteristics of the models that we'll look to have in production.
Do you have any data that you're able to share in terms of the greater accuracy you have, in certain models, or some way to compare it in terms of what exists today?
Yeah, so in our website, we have a page that is called DECInets that kind of presents the efficiency accuracy trade-off between our models that we call them DECInets for a few examples of classification, object detection, etc. On various types of hardware compared to all known models in open source, or at least most of them, like ResNet family, EfficientNet by Google, MobileNet that also developed by Google. And what we consider is that when we put the models as a points on a 2D grid between accuracy on the y-axis and latency on the x-axis, what we can see that our models kind of breaking the efficiency frontier of the existing models, letting us get to a new level of performance or new level of trade-off between accuracy and latency, which can result with 2x improvement in latency while preserving accuracy, or by having the same latency with addition of 2 to 3% of accuracy for some models. And this is kind of the numbers that we see on that models also when applied to customers' data and not only benchmarks based on open source datasets.
You should issue a challenge out there to see if anybody can beat your accuracy. That would be a great case and study. Say, look, we're better than anybody else. You can't beat it. Throw it out to Kaggle or something. Anyway, so then I go down. So we provide proprietary optimization technology for deep learning practitioners. Obviously, deep learning. These are the data scientists under the CDO of the organizations you're working with, I presume, something like that. Is that the persona you're looking for, or more?
Yeah, so basically deep learning usually developed in engineering organization more than a CDO in the classical machine learning, in the classical data science disciplines. Usually we engage with tech teams that are building product features that are in computer vision mostly, or NLP, that are engaged in the engineering organization of technology companies. This is where we find the deep learning developers or deep learning practitioners today.
Anything that can be said on your claim to accelerate deep neural network inference?
So inference is the stage of running the models in production. When we want to take those algorithms and run them in production, we have one option: to scale them on better hardware, go to the new NVIDIA GPUs, and sometimes even that is not sufficient, especially when we want to work on constrained hardware at the edge when running complex algorithms that could run on video in real time or applications like that. And in those cases, the acceleration of the performance of the inference of the model is heavily needed on that use cases and scenarios.
That makes sense. And then preserving accuracy around hardware. We talked about that earlier in terms of being able to handle multiple edge devices. What is the most common hardware that you're working against right now?
Edge inference or production, AI in production at the edge is NVIDIA and Intel are the most prominent hardware, and after that we see some Google Edge TPU hardware, some Qualcomm, some AMD, and ARM processor. So this is kind of the distribution, but most of them we see on dedicated AI hardware by NVIDIA, the Jetson family. And after that, we're seeing with people trying to run AI on standard CPU. For example, one of the applications is when we run video conference application and we're using the feature of the background removal or the virtual background, what we see is that actually semantic segmentation algorithm is running on the edge device, on the CPU of the laptop, removing the background and filling it with a virtual background. So this is an example for edge AI deployment of computer vision algorithm that is running on real time and trying to get the best accuracy in order to do the segmentation in the best accuracy available in the highest image resolution, etc. So for example, this is an application that's running on the edge on CPUs. Another application is usually home and office security application where smart cameras are connected to edge devices, dedicated hardware for processing, computer vision, video processing. Those could be the Jetson edge devices. So this is another example for application where we want to feed as maximum as the cameras that we can put on existing hardware or on one unit of hardware. And usually by boosting the performance of those algorithms, we can improve the economics and the total cost of ownership in getting more and more cameras or more and more streams running on the same inference hardware.
Wow. You're like the CTO and CEO combined, I think.
Yeah, I'm a CEO that is coming from a technological background, which is sometimes is an advantage and sometimes a disadvantage.
I'm sure that's the case. I got you. Yonatan, interestingly, look, I've ran an AI business myself, and we were focused a lot on bias. I don't see anything there about bias. Could you talk to, is it not of concern, or do you think it's out of scope? What are your thoughts there?
Bias is definitely a concern in AI, but I think that as we are focused on the model and the source for the bias is usually coming from the data, is something that in some sense is out of scope from technological perspective of the value proposition that we are providing. We do have some feeling of responsibility of the models that people are building based on our technology and products. So we want to give them the tools and the ability to check and monitor the bias. But this is something that we're looking to in our roadmap on how we can grow the product in and tackle more aspects of the end-to-end life cycle, like monitoring and detecting bias in the prediction, both pre-production in the QA stage of the model and also when running it in production. So at the moment, bias is coming mostly from the data, and I think that it's one of the jobs of the data scientist to make sure that the data is unbiased. And the second thing is that we should help data scientists to monitor and detect the bias after building models on our tools.
I take that as you're still advancing. That makes perfect sense to me. And I get you that you have bias in the data, but I think a lot of people out there would say you can't have bias in the models. Will you work with the data scientists then, or the deep learning practitioners to ensure that that's not the case? And or is there third-party tools you use today?
Basically, what we tell the customers is to do the QA that they're doing for their models the same as they were doing before DECI. We encourage them to test the models that are built by DECI on the same characteristics and the same properties they did before. And by that, we kind of encourage them to see that the performance based on the model is similar on all aspects, not only bias, by the way. And I think that this is something that should be integrated into the standard procedures of data scientists before taking model to production. I see some of the companies that are better on that, and some of the companies need more tools in order to do that better. But also, I see some domains that bias is more, let's say, important or prominent, and some other domains that bias is less significant. For example, in NLP, bias is very well, on one hand, defined and can be detected and found. And in computer vision, sometimes the bias is less prominent in computer vision algorithms. But we see also examples that there is bias in models of computer vision, but less than what we see in NLP.
All right. So taking this up a bit, when we started the podcast, I started with, hey, Yonatan, maybe I put words in your mouth, but I said, argues that for AI to be practical, we need better algorithms, et cetera, and to drive ease of deployment. What's your definition of AI to be practical?
I think that practical is kind of what is the barrier of entrance into AI, both in terms of the amount of hardware and infrastructure you need in order to get an AI application up and running. It's the infrastructure you need to train models, or the availability of pre-trained models. The second thing is the proficiency that you need in order, first, to build a model, and second thing, to get it into the application or into production. And we are looking how to reduce the barrier of all of these aspects in making AI more accessible and more practical.
Let me key on the ease of deployment. I totally get your focus, and I also get your sweet spot, which is, as we talked about, IoT or edge devices. Before I ask this question, I got to ask you a question on edge devices while I'm thinking about it. Where do you think we're going with edge devices? I think I got to believe in part of your pitch to venture funding, you talk about not just the AI needed in edge devices, but the ramp up in edge devices we're going to see in the industry. I've been studying this for quite a while, and I'm just surprised edge hasn't taken off even more than it has today. I don't know where your thoughts are. They're just taking a business fork in the road here for a second, but I got to believe that enters into the equation here, and particularly given it's your sweet spot.
I think that we see kind of two trends that are opposite. One of them is the world is going to more and more SaaS applications. So today you have even Microsoft Word or Office in the cloud. But on the other hand, we see more and more of those workloads working on the edge, with some advancement in JavaScript applications and in-browser applications that actually working on the edge while are connected to the cloud. So it's kind of the opposite trend. We see the SaaS that's bringing everything to the cloud, but I think that after that, we're starting to see more and more applications that are going to the edge, more and more distributed computing and computing near the data, because we understand that we are collecting a lot of data and we don't need to transfer it all the way in order to process that. Also, the edge device processors are getting better and better, enabling us to do more of the processing close to the data or close to where the data is collected and gathered. And at the end of the day, it brings some advantages of having the data stay close to the device. So it improves the security and the privacy of the data, reduces the communication to the cloud, improve the user experience, and getting kind of immediate response and not waiting for some latency over communication and cloud computing in order to get a response from the application. And I think that everyone today tries to push more and more applications to the edge.
Look, I like that you went out on a limb. I don't know if you went out on a limb, but you went out and said, look, edge is our sweet spot. I have a lot of people on this podcast, and we're talking about AI models pushing from cloud to this or that, but you're the first that's really has come out and said, look, edge is our sweet spot. We start there and then we go elsewhere. I think that is a differentiator for you today. So I hope you continue with that. And I think that'll be your success factor. Hey, back to deployment. The one thing that in my mind, look, having run AI organizations in the past, I look at the life cycle, and I know you're keen on edge, which is great. We talked about that, and you're keen on deployment, keeping things accurate and deployed. However, to get to there, I mean, like you look at the AI lifecycle, I got to gather data, I got to prep data, I got to wrangle data, I got to analyze data, then train it, model it, and then deploy it. I mean, so the deployment's at the end of that lifecycle. Does your software handle the first 5 to 6 elements that I just went through? Or are you saying, hey, no, you've got to be intelligent enough, Mr. Customer, to get through that? So you're starting to create models. That's where I'll come in and help you finish that model. I'll give you that model, that prescription, and then we'll get it deployed with accuracy. Or do you start at the gathering data like anybody else?
We started right after you gather the data. We see AI landscape is very fragmented into silos. So there's the data gathering, labeling, cleaning part, there's the modeling part, there's the deployment part, and we're seeing it as, since you have the data, you can go with DECI until production, and also after that in retraining and updating the model. So this is kind of where we enter, and we take all the way in an end-to-end fashion until production.
So now I also get why you say earlier, hey, a lot of the what you see is a lot of the biases in the data itself. Because I got to believe you go into these organizations. I mean, you tell me, but I got to believe there's a lot of times you're looking at it and going, oh, you said your data was ready. The data is not ready. I mean, and then what do you do? I mean, that's got to happen relative to what I see in the industry. Yeah.
Yeah, usually when we have a first call with the customer, they are telling us that the data will be ready in 2 or 3 weeks. And what we see in practice, that it is taking 2 to 3 weeks on the time that they estimate that they will be ready with the data. So yes, data is a big challenge today, but I think that we see as the first step in the life cycle, we see many, many tools that help there. We are not data experts, we are model experts. So we get into the job right after you have the data and need to build the best model based on that.
That makes sense. That's perfectly fair. I get it. I just got to believe you're in there. I know you're not data experts, and I respect that. I mean, too many people try to do everything.
Yeah.
And at the same time, I got to believe you're going in there going, oh my gosh, guys, and you're starting to provide services on the data saying, hey, you need to think about this. I'll come back in 3 to 4 weeks. We'll try again. I mean, look, you've got to be doing that, I believe. I mean, I don't want you to out your customers, but I know that every customer is in that situation.
We tried to understand before engaging that they started to build some models on some tools to see, like, the best way to measure that you have the right data is that you can get to some level of accuracy when trying to build the first model. So if you are 20% far from where you want to be in terms of accuracy, the best model in the world will not help you. You probably have a problem with your data. But if you're 5% away and 2x in latency, then you can use DECI and get the additional boost.
Makes perfect sense. I like it. I like the model. I like the edge, like I said. Kate, my famous producer, do you have a question? Anything you'd like to ask?
I do. I'm going to go back to the question that I really wanted to ask earlier, which is, how does it compare, having the engineering brain and the business side of things, how does it compare to developing the technology and developing the business, right? So how do those two compare? Which is harder? That was my joking question I had earlier. And then what advice do you have for entrepreneurs who are looking to make the change from investing all of their energy in technology, which is what they might be comfortable with, what they're doing today? How do you shift those skills?
The first step is to understand what you're good at and what not. And
knowing yourself, right?
Yeah. And I think that you need to choose the right position in the company where you're founding a startup. If you don't think that you're the right man to be the CEO, don't be the CEO. But if you think that it's something that you can learn and close that gap, even if you don't have 20 years of experience in business, then the next step is to surround yourself with the right people, with the right advisors, with the right investors that will help you to close that gap in order to build a strong business. This is kind of what I have did at DECI when choosing my investors, choosing my advisors, and choosing my early employees.
I think that's very wise. I don't know what you think, Kate, but
Yeah,
I
surrounding
see
yourself with a team.
Yes, the most successful startups I see are those that realize where they're good, and a lot of times, it's vice versa too. I'm the technical person. I'm going to give the CEO up, and I know that hurts, particularly when they're a startup, but they do well because of it, because somebody else comes in that's run that business. Man, this has been a great discussion. I appreciate it. Where can folks go learn more about you, Yonatan, and or DECI?
So actually, in our website, we have a lot of details and white papers on DECI. Also, there's an access to our platform that is completely free, and people can use and try to build some models on top of that. So this will be kind of the right way to go in order to learn more about DECI. You can also contact us and book a demo. So we'll be happy to meet in person.
Fantastic. Anything that I didn't ask you that you wish I would have?
Nothing that comes to my mind now. I think that we covered everything about DECI and about challenges in building AI models that I wish that will be easier in the coming years.
Very good. Hey, before I let you go, I'll play a very quick little game with you. Have you ever heard Would You Rather? You got to pick one or the other.
Okay.
All right. So
you can't lose at this game. It's good.
But you got to pick one or the other. All right.
Mm-hmm.
So this is how the listeners get to learn a little bit more about you. AI driver or human cars?
Human cars in the next 5 years.
Do you hire for culture first or skill?
Culture.
Well, see, that's all right. In person or remote?
In person.
I figured that would be the case. iOS or Android?
iOS.
Okay. And this is probably an easy one too, but startup phase or accelerated growth? What's more enjoyable?
That's a good question. I think that accelerated growth is most fascinating.
All right. So I know, and you're heading in that direction. Hey, what do you do for fun, by the way, before I let you go?
Family and travel, hopefully together.
Where's the best place you've traveled?
I think that one of the best trips was California national parks.
Very nice. Very nice. Well, Yonatan, I appreciate you being here. Learned a lot as usual. You did a terrific job. Thank you so much.
Thank you very much. Bye-bye.
See you. And listeners, again, thank you. As always, please rate us on any of your favorite podcast flavor of choice. And hit us on almartintalksdata@gmail.com if you have any comments, questions, concerns, or you want to be on the podcast. See you all later. Bye-bye.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit ibmbigdatahub.com/podcast to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests, and do not necessarily represent the views of IBM. Until next time, let's go. Over and out.